This video is going to look at questions 4, 5, and 6 on the midterm review over interfaces and classes. Question 4 over interfaces, we're given this interface named I, and notice that, so interface I has two method headers. Notice the code for the body of the methods are not written in interfaces. The purpose of an interface is to dictate what methods will be required within any class that implements it. Here we have a class C that implements I, and the question is, what must be true about the code for class C in order to compile successfully? And you must have a method with a similar header in the class. So you'll need an M1 method with a similar method header and an M2 method with a similar method header, and then your code will compile. It will not compile as written. For question 5, you will be given a UML diagram. It'll be a UML class diagram, and you will need to be able to determine some terms based on the class diagram. I provided two class diagrams, and can you identify a parent class or superclass? So for example, I hope you look at this and you would say that stock is a parent class of dividend stock. You should know that. Or customer is a parent class or superclass of corporate customer or personal customer. Cardinality determines in an association or an aggregation how many relations there can be between two classes. So these numbers here that create the association, for example, show us the cardinality. One customer can place many orders. That's all that's saying. One order can have many order lines. For example, I ordered off of Amazon yesterday. It was one order, but I placed two items on the order, and that's what an order line would be. The is-of relationship, can you determine what an is-of relationship? And this is an is-of relationship. A corporate customer is a customer, and notice the triangle. Coming up here, a dividend stock is a stock. Triangle or arrow going to the parent class. And then the has a relationship would be this diamond. So an order has one or more order lines. Its aggregation is a has a relationship. On question 6, we have a subclass again and a parent class. You just need to know how to call the methods in the parent class from the subclass, and that's that keyword super. Here we have student, and here we have an undergraduate student that extends student, both classes, and you are asked to write the constructor for the undergraduate student that calls the constructor for the parent class. So the constructor in the parent class has two parameters, and we have to match that when we call that. Public undergraduate student, you must at the minimum have a string and an int. It does not have to be the same names. To call the parent class, you're going to write super and go ahead and send name and age. And this code would satisfy the question. So this is the minimum. By the way, there could be more in this constructor and still call the super. Just because student only has the name and age as a constructor does not mean that undergraduate student requires exactly the same thing. So it is possible, since there is a year private variable and it is type int, that I could have a year here. And then after calling the constructor, I can assign to year. Here I am assigning to year. It's not a part of the call to the parent class. I just have to make sure the call to the parent class matches the parameters of the constructor in the parent class. If there are other fields, you can create constructors that have those extra fields in them. For question 7, you're asked to write the source code for a simple subclass. What we're going to see is that you know that you need to extend the parent class in the class header, and also take a look at number 2. The class members are model name and number of seats. And we're checking here if you know how to use access modifiers, because model names should not be accessible outside of the class. What access modifier would you use when you declare a model name? Number of seats should be accessible to any class that extends the class car or is in the same package. So you know about private and you know about public. Just to review, in week 2, we also discussed the protected and the default access modifiers. Let's take a look at how the text defines protected. So protected access means it's visible to this class and any subclass and any class with the same package name. The default simply means that you do not even add an access modifier, and it is visible to all classes that has the same package name. To create the class, we have public class car. Since it is child class of vehicle, it will extend vehicle, extends vehicle. We have a couple of members then in part B. So model name should not be accessible outside of the class. That's simply private. And number of seats should be accessible to any class that extends it or is in the same package, and that is the definition of protected. Number of seats would probably be int. Make sure you put your data type in there. And that is the solution for number 7.